Okay, so we're going to take a moment to graph 3 exponential functions. So there's no real rocket science to graphing these. You do the most basic, use our most basic method of graphing, which is making a table. It works for all kinds of equations, especially those that you have no clue about. Just make a table and see what points you get and see what it looks like. So we make a table, we plot those points, and draw the curve. And then we will start to describe the domain and range of all of these graphs, okay? So here's a basic exponential function, and we're going to make a table. And when we don't know what's going on with a graph, what do we normally use as inputs? We use 0, we use 1, 2, we use -1, -2, right. We use a couple negatives, 0, a couple positives. And if we put them in order, least to greatest, we should be seeing the pattern that should come out of this, which is what pattern again? Constant multiplication, right? Good. So when we plug in 0, we're using this equation, 3 to the 0 is? Good. When we plug in 1, 3 to the first is? When we plug in 2, 3 to the second is? When we plug in -1, what does a negative do? 3 to the -1 equals?
1/3.
What does it equal? 1 over 3 to the first, or 1/3. Good, 1/3. And 3 to the -2 gives us? Good job, 1 over 9. Okay, this is interesting. So we go plot. 0, 1. 1, 3. 2, 9. -1, 1/3. -2, 1 9. What if I put in some other, what about -3? What would I get? -3,
1/27.
1 over 27. Good. -4, 81, right? 1 over 81. -5, 1 over. Do you see how the denominator just gets bigger and bigger and bigger with a greater negative exponent, right? Will it ever give me a negative product? 3 times itself over and over again, will it ever get negative? No, we're never going to be negative. This denominator is just going to get bigger and bigger and bigger, which gives us a smaller and smaller and smaller fraction, right? So this graph is approaching 0, but never will reach it, okay? And then it's going up, 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 steeply here. So it's kind of hard to show this, but you're seeing that it's getting flatter and flatter. It's approaching 0, and that's the best I can show here. Okay? So let's talk about the domain and range. What x values are you allowed to put in? We put these 5 in. Could we go more negative? How far? Infinitely far. Okay, could we go more positive? How far? So for the domain, we say we can use all real numbers. Okay, for the range, no matter how small our numbers get, we said we'll never hit 0, right? So the y values are always going to be greater than 0. And the y values up here, you know, they're getting really big, aren't they? So we're approaching infinity there, but we're never going to cross over the 0. We're never going to hit it. We're just going to have the tiniest of fractions. Okay? So this is different than our linear equations, where we, in most cases, go infinitely in the y range in both directions. Okay? Okay, so finally, what we'll do is graph 2 functions and compare them. We're going to start to look at what transformations happen when you just tweak it a little bit. So these equations look almost exactly alike. The blue equation is different how? Matthew?
1/3 is negative.
It's negative. That's the only difference. So let's see how that negative affects the A. Negative A there. Opposite A, otherwise same value, affects the looks on a graph. Okay? So we'll make 2 tables. And we'll use those same values. And let me have someone help with this. Johnny, when we plug in 0 here, 2 to the 0 is 1, and 1/3 times 1 is 1/3. So we end up with 1/3. That's a 3, 1/3. When we plug in 1, Johnny, 1 right here, 2 to the first is 2 times 1/3 is 2/3. Good. 2 times 1/3 is 2/3. When we plug in a 2 here, what is 2 to the second? 2 to the second is 4, and 4 times 1/3? 4/3, which is what mixed number? 1 and 1/3. Okay? When we plug in -1 here, -1 causes this 2 to go to the inverse location, right? So we end up with what number there? 1/2. Good. What is 1/3 times 1/2?
Hey, Dad, please come to school office for a moment, please. Hey, please come to school office.
Okay, how about -2? When you plug in a -2, we get 1 over 4. 1/4 times 1/3. 1/12. Okay, let's go graph that. 0 is at 1/3 now. 1 is at 2/3. 2 is at 1 1/3. -1, -2, they're getting close to 0. So how does this look different than the previous graph? Okay,
It's not as steep.
good. It's flatter. We call that a vertical shrink. It's flatter away from the y-axis. It's not stretching up closer to the y-axis. It's shrinking back. Okay? Now, how about this second function? We have negative, or let's start with 0. When we plug in 0 here, 2 to the 0 is? 2 to the 0 here is 1, and 1 times -1/3 is? -1/3. When we plug in 1 here, 2 to the first is 2, good, and 2 times -1/3? Good, -2/3. We're simply plugging them in. When we plug in 2 here, 2 to the second. 2 to the second is 4, good, and 4 times -1/3? -1. Do you see something similar to this other function? They're just all the opposite. So we can just go fill this in. 1/6, -1/6, -1/12. Okay, so how does this look on the graph? It is, it's all the opposite. Good. So we have 1 at -2/3. Whoops. 2 at -1 1/3. Closer. We draw the curve. Good. So it looks opposite. And how would we describe that transformation with more technical terms? Who can use a better term than just opposite? It's like a mirror, but the technical term for a mirror is, begins with an R. Good, reflection. So we would say that the blue graph is a reflection in the x-axis. And as was just said, that a value equals 1/3 is a shrink, a vertical shrink of the previous graph, right? What was the previous graph's a value? Oh, it was 1. Okay? So what was in front of that was a 1. Okay. Any questions? What is the domain of the black graph? This domain, what may we put in here for x values? All real numbers again, all real numbers. And the range, y values are what?
Oh, greater than
greater than 0. So let's compare that to this one here. The domain of the blue one, x values may be all real numbers again, all real numbers. I'll use that for numbers. And the range now are not y values greater than 0, but they're all less than 0. So that's a dramatic change. And that's due to the negative a. The negative is the only thing different, and it causes the range to be completely opposite. Okay? Any questions? Okay, then your assignment is here. And you will need graph paper. And use your concept book to help you.